In this video, we'll talk about how to troubleshoot your system following a number of steps iteratively until solutions are found. Check your network and file integrity for possible issues. Resolve the problems when there is a system boot failure. Repair and recover corrupted file systems. Understand how rescue and recovery media can be used for troubleshooting. Okay, let's begin. Troubleshooting levels. Right, there are three levels there: beginner, experienced, and wizard, right? Beginner, this level can be taught very quickly. Experience, this level comes after a few years of practice, right? So wizard, some people think you have to be born in this way, but that is nonsense. All skills can be learned. Every organization should have at least one person at this level of expertise to use as the go-to person. Even the best administered systems will develop problems. Troubleshooting can isolate whether the problem arises from software or hardware, as well as whether they are local to the system or come from within the local network or the internet. Troubleshooting properly requires judgment and experience, and while it will always be somewhat of an art form, following good methodical procedures can really help isolate the sources of a problem in a reproducible fashion. Basic troubleshooting techniques. Troubleshooting involves taking a number of steps which need to be repeated iteratively until solutions are found. A basic recipe may be characterize the problem, reproduce the problem, always try the easy things first, eliminate possible causes on one at a time, change only one thing at a time. If that doesn't fix the problem, change it back. Check the system logs, var log, messages, var log, secure, etc. for further information. Sometimes the ruling philosophy and the methodology requires following a very established procedure. Making leaps based on intuition is discouraged. The motivation for using a checklist and a uniform procedure is to avoid a reliance on the wizard. To ensure any system administrator will be able to eventually solve a problem if they adhere to well-known procedures. Otherwise, if the wizard leaves the organization, there's no one skilled enough to solve tough problems. If, on the other hand, you elect to respect your intuition and check hunches, you should make sure you can get sufficient data quickly enough to decide whether or not to continue or abandon an intuitive path based on whether it looks like it will be productive. Well, ignoring intuition can sometimes make solving a problem take longer. The troubleshooter's previous track record is the critical benchmark for evaluating whether to invest resources this way. In other words, useful intuition is not magic, it is a distilled experience. Things to check: networking. Network problems can be caused either by software or hardware, and it can be as simple as is the device driver loaded or is the network cable connected. If the network is up and running but the performance is terrible, it really falls under the banner of performance tuning, not troubleshooting. The problems may be external to the machine or require adjustment of the various networking parameters, including buffer sizes, etc., right? So what to check when there are networking issues? You can check IP configuration, network driver, um, connectivity, default gateway and routing configuration, host name resolution. Let's discuss one by one. IP configuration. Use ifconfigure or IP to see if the interface is up. And if so, it is configured, right? Network driver, if the interface cannot be brought up, maybe the correct device driver for the network cards is not loaded. You can check the LS mod if the network driver is loaded as a kernel module, or by examining relevant pseudo files in proc and sys, such as proc interrupts or sys class net, right? Connectivity, using ping to see if the network is visible, checking for response time and packet loss, trace route, can follow packages through the network, well, MTR can do this in a continuous fashion. Use of these utilities can tell you if the problem is local or on the internet. Default gateway and routing configuration. Run route-n and see if the routing table makes sense. Hostname resolution. Run dig or host on the URL and see if DNS is working properly. Things to check: file integrity, right? There are a number of ways to check for corrupt configuration files and band arrays. For RPM-based systems, to use RPM-V, some package, right? To check a single package, you do RPM-VA, checks all packages, right? And in Debian, the only way to do integrity checking is with deb sums. Running devsums, some package will check the checksums on the files in that package. However, not all packages maintain checksums, so this might be less than useful. You do devsums options some package, right? Aid does intrusion detection and is another way to check for changes in files. You do aid dash dash check. We'll run a scan on your files and compare them to the last scan. Boot procedure failures. If the system fails to boot properly or fully, being familiar with what happens at each stage is important in identifying particular source of problems. Right here are the boot process failures. You can see it on the screen, right? No boot loader screen. Kernel fails to load. Kernel loads but fails to mount the root file system. Failure during the init process. Let's discuss one by one. We start from the first one. No bootloader screen. Check for the grab misconfiguration or a corrupt boot sector. You may have to reinstall the bootloader. Where kernel fails to load, if the kernel panics during the boot process, it is most likely a misconfigured or a corrupt kernel, or incorrect kernel boot parameters in a grab configuration file. If the kernel has booted successfully in the past, either it has corrupted or bad parameters were supplied. Depending on which, you can reinstall the kernel or enter into the interactive grab manual at boot and use very minimal command line parameters and try to fix that way. Or you can try booting into a rescue image. Kernel loads but fails to mount the root file system. The main causes here are, could be a misconfigured grab configuration file or a misconfigured etc fs tab or no support for the root file system type built into the kernel or in the init RAM-fs image. Failure during the init process, there are many things that can go wrong once init starts. Look closely at the messages that are displayed before things stop. If the things were working before with a different kernel, this is a big clue. Look out for corrupted file systems, errors in startup scripts, etc. Try booting into a lower run level, such as 3, no graphics, or 1 single user mode. File system corruption and recovery. If during the boot process one or more file systems fail to mount, FSCK may be used to attempt to repair. However, before doing that, one should check that etc fs tab has not been misconfigured or corrupt. Note once again that you could have a problem with the file system type, file system type the kernel you're running does not understand. If the root file system has been mounted, you can examine this file, but slash may have been mounted as read-only. So to edit the file and fix it, you can run sudo mount-o remount rw root. To remount it with the right permission, if etc fs tab seems to be correct, you can move to fsck. First, you should try sudo mount-a to try and mount all file systems. If this does not succeed completely, you can try to manually mount the one with problems. You should first run fsck to just examine. Afterward, you can run it again to have it try and fix the errors found. Using the virtual consoles. By default, Linux defines 12 virtual consoles, also called virtual terminals, to allow local access to the system. The first 6 are usually login text consoles. Console 1 is used by most distributions as the system console. The 7th is usually the graphical console. If you have one, however, some distributions, including RHEL, use console 1. You can use control alt fx, where x is the number of the console. To go between the consoles, for example, control alt F5 goes to console 5. Okay, this is the end of this video. Thank you for watching. I will see you in the next one. Bye for now.